G'day guys, today's video we're replacing the bathroom heater. The customer has gone and picked up a Serene S2068. So the first thing we'll do is crack into the box. In this package here, you'll find some operating instructions. On the first page here is a wee outline of the diagram. You can see 200 mils from the ceiling, we don't have to worry about the sides, and 500 above an object. So we'll just double check and verify that those dimensions are okay. From the ceiling down, 200 millimeters is above the unit, which is decent clearance for the new unit. And from the top of the towel rail below, 500 millimeters is below the bottom of the existing unit. So as long as we position the new unit exactly where the existing one is, we'll have no problems dimensions wise. Before replacing an existing wall heater, it's good to know that the new heater's base is going to cover the existing hole on the wall completely. If it doesn't, then you may want to make the homeowner aware of that before you attempt to remove the heater off the wall. When replacing bathroom heaters, because the bathroom is considered a damp area, we need to ensure that the new heater we're installing complies with today's wiring standards and regulations. Sometimes you'll find existing heaters are located far too close to showers and other water containers. Under section 6 in the wiring rules, you'll find all the relevant information with zoning and wet areas. This heater here is well outside of any zone in this bathroom, as the bath is located well over there, and on the other side of the bathroom, down the end there, is the shower. Now another precaution we want to make sure is to verify the existing unit's kilowatt rating and the kilowatt rating on the new unit, ensuring that the new unit is equal to or less than the existing unit, because this may save you time down the track in realizing after you install it that hey, the circuit or cable supplying the unit isn't adequate for the amount of power this consumes. On top of the bathroom heater here is a label that displays the wattage rating of the existing unit. Now this is 2200 to 2400 watts. Comparing it to the new heater here, it is identical. You can see the wattage is 2200 to 2400 watts. The next thing we're going to do is isolate this unit at the switchboard. For the first part of isolation, I'm going to turn this heater on in the bathroom and leave it running while I go to the switchboard and turn circuit breakers off until I can confirm that I've turned the right circuit breaker off. I'm lucky this heater is still operational, so I can still hear it outside of the room when I go to the switchboard, which will make identifying the circuit breaker a little bit easier. So I'll turn it on now and go to the switchboard. So I'm at the switchboard here and I can still hear that bathroom fan going from across the hallway. Now I'll turn power circuits off and back on until I can identify exactly what one turns the bathroom heater off. Sounds like the bathroom heater is on this circuit breaker here. Now is also a good time to ensure that the bathroom heater is on an RCD. As you saw, the RCD operated perfectly and the bathroom heater turned off. So I'll turn that circuit breaker off and I'll lock that circuit breaker out. Now that it's locked and tagged out, no one's accidentally going to be able to turn it back on while I'm working. As you can see, the isolation switch is still turned on in the bathroom here and the heater is not functioning anymore. So we can safely turn that off and start removing the heater. On this particular model, there is a bracket screw right underneath the center of the unit. So you can throw a Phillips screwdriver underneath it. Beware of the wall, we don't want to leave marks on the nice paintwork. It doesn't need to unscrew all of the way, but once it's out, you can then lift the unit up and it will clip into place. Now this heater's up, out of the way, we need to remove the cable. To do that safely, we first need to verify that the cable here is in fact dead. We always need to test before we touch any cables. Before using a multimeter to test the circuit with, we need to verify that the leads on the multimeter are intact. And then the second check we need to do is to prove, test, prove on a known live circuit to ensure that this meter is reading the correct results. First we'll put the meter on ohms, touch the two cable ends together and ensure it's 0.0 or close enough to it. Then we're going to throw it into volts AC and we're going to test a socket outlet that we know is live. So testing at the first outlet here, we can see the meter is capable of reading 240 volts on a circuit. Testing at the heater here, we can see the meter is displaying there is no voltage on the cable here. We'll test between phase and earth and phase and neutral. And then we verify that once again the meter is able to determine 240 volts at a known live power outlet. So we can be assured this cable is in fact dead and we have delivened the correct circuit for the bathroom heater. The next stage of course is to remove the cable cores. Once you've verified they are dead. Once the cable's been removed, we can then go ahead and remove the two bottom bracket screws and loosen off these two top ones so the meter can pop up and slide off. Once the screws are loose and out, you can push that cable into the wall a wee bit, but we don't want to lose the cable inside the wall. Simply lift the heater off. Now get rid of the two top screws. Now is a good time to identify the size and integrity of the existing cable, ensuring that it's at least 2.5 mil. If it's less than 2.5 mil, or the distance from the switchboard is quite far, you may want to do a cable calc before you install the new heater to ensure that the correct cable size has been used previously. And especially if the cable here is not TPS, then you probably want to replace that pretty quickly. Now's the best time to let the customer know if the cable does need replacing and explain to them why, especially if it's a quoted job. Alright, so I've got the new heater here. I've strategically placed it on carpet so I can safely flip it upside down without worrying of marking the stainless steel behind this plastic protector. When removing the bracket off the back of it, there is two clips, one on either side, that you'll have to push in with a screwdriver to clip it off. And there we go. Before removing the bracket from the heater, you want to make sure you know the orientation of the bracket. So this here is going to be the top and this here is the bottom. Now this stage here is generally a good place to do a continuity test and verify the earth. This unit here does not have an earth and it has the double insulated symbol right there. Therefore I can skip that step on this heater. Carefully get rid of the dust. So the bracket is to be at the same height as the paintwork. You can see the difference in colour of the paintwork where the old heater used to sit on the wall. Now we want to centre that up for our new heater to go on the inside of that. I'm going to run into a wee bit of trouble here because of the location of where this cable comes through the wall. So I'm going to want the cable to come through this hole here inside the new bracket, which as you can see is going to be further to the right hand side of where it is. I also want the edge of this bracket to cover up those existing screw holes so you cannot see them from any angle behind the wall heater. I've gone and got my pencil and drawn a square around where the cable needs to come out of the wall. Because this existing cable goes through a stud, you can see the timber on the inside of the wall. I can verify it's a stud by the noise difference in the wall here. Therefore I'm going to have to cut a chase across to the square and cut the square out a wee bit with a multi-tool. Before creating any dust, we want to ensure that the environment is clear of the homeowner's belongings. So I'll be removing these two towels from the towel rail and ensure that there's no other property on the floor that could get dirty or damaged from the dust. As you can see, I didn't opt for taking the entire square out because the cable only needs a small gap to be able to pull through on. So I'll relocate that cable into position. And now I'm ready to install the base on the wall. I'll line it up with where I want it and ensure that it's level. Now I'll go around the unit and put pencil marks in each of the screw holes in the bracket. Now I found that my builder's pencil was a wee bit fat to fit in the holes, so I went around with my little terminal driver and poked some small holes where I need to put screws into the wall with. So I don't get any issues with my new bracket sitting flush with the wall, I'll go around and remove these nylon wall plugs with my Phillips screwdriver. I may end up reusing these ones for the new bracket. Once they're removed, I'll go ahead and poke my screwdriver through the new holes to check if there's any fixing behind them. So none of the new holes have fixing. I'll burr them around with my screwdriver and ensure the holes are big enough for the nylon wall plugs to screw back into. Once the wall plugs are in the correct locations, we can then start screwing the wall bracket to the wall. Make sure you're using stainless screws for this type of environment. Once you've got one screw in the top corner, chuck the level on and ensure that the bracket is level before screwing any other screws into it. Now that the bracket's mounted, I'm going to cut the end off the earth cable and safely screw a connector onto the end of that cable because we won't be using that on the new unit. Then on the other two ends, make sure the copper is twisted up nice and tightly. Now that I'm back at the heater, I've got the cable ends in my hand. Before I install this heater on the wall, I want to make sure I put some connectors on the end of the cable so I'm not holding the heater in the air for a long period of time. This is a flexible cable, and because I want to put it into screw terminals, I want to throw some bootlace or ferrule crimps on the end of each cable core. So I'm going to straighten out the copper strands to make sure that the bootlace is going to slide directly onto it fairly easily. Once I've done that, I'll slide it into my ferrule crimper, push it all the way on as firmly as possible and crimp down. Do the same on the neutral cable here, and I'll tidy these up by trimming just the copper ends off. So I'll make sure I trim them into a box and not onto the customer's carpet, and then these two ends can be placed directly into these connectors. Now these cable ends are ready to install on the wall. I've intentionally set the heater on top of the ladder, so I'm being very careful that I'm not going to knock it off. I'll install the phase cable into the strip connector first, so the red cable will connect up to the brown cable in the flexible cord, and the black cable will connect up to the blue in the flexible cord. Now I'll inspect each connection point and ensure that the screw has clamped down onto the copper, and then I'll conduct a pull test to ensure there's no loose connections in these connectors. Now that I'm satisfied, I'm going to coil this flexible cable up and push it into the wall through this hole here. So I've inserted the flexible cable into the wall and left the two connectors on the outside of the heater here, so they're easy to get to in the future. I've also left enough length on this flexible cord to place through the slot where it needs to go, so I can install it appropriately. Before you throw the heater back on the wall, you want to ensure that these holes are completely filled with silicone or Firecreel, whatever you've got on you. What it does is prevents dust coming out of the wall and getting sucked into the back of the heater, which will compromise the life expectancy of the heater, considering once they're installed, not many people are going to service them at all. As you can see, I've completely sealed these holes. Now it's best not to use the heater until the silicone's completely cured, so give it a number of hours and you'll be sweet to go. The next thing to do is to simply clip it in place. Now that the heater is in place, it's always a good idea to double check that it is level on the wall. I've finished handling the heater, so now's the best time to remove the protective blue film over the stainless steel finish. We also need to ensure that it is removed prior to livening up the heater so it doesn't melt to the outside of it. We can safely remove our lockout tag for the switchboard now that we're ready to liven. Turn the isolator on and pull the pull cord. The final part is deciding what to do with the pull cord. With the pull cord, I've simply tied it up just like that and thrown it so it's just behind the bracket on the side and outer side. It does look much nicer to cut them off flush with the heater, but at the end of the day, bathroom heaters more than any other appliance have a lot of warranty issues. So it's best to keep the product in its original form when you're installing it, or you may have trouble further down the track should you need to do a warranty claim. One other thing before installing a bathroom heater is you want to make sure there is an isolator separate from the heater available. Sometimes with old heaters that were installed in the 80s and 90s, they do not have these isolators or they're built into the unit. The isolator nowadays must be separate from the heater itself. When you finish the install, don't forget to brush all of the dust away and vacuum it up. Cheers for watching everyone. Subscribe for more of these types of videos.